Hey, everybody. We are in the Tennessee Revealed Geometry, and this is lesson 4-3, which is on rotations. Rotations is basically when you take a figure and you turn it. Now, if they don't tell you which way to go, it is counterclockwise, which you guys is to the left. All right. They have to specifically say clockwise. So if they don't tell you, it is counterclockwise. Okay, so let's get into it. Okay, looks like this one's not about the origin, but let's talk about the origin real quick. These are your formulas for a 90-degree rotation counterclockwise, 180-degree rotation counterclockwise, and 270-degree rotation counterclockwise. So these are all of your little cheat codes that I've mentioned before in my videos. So one more time, these are all to the left. So if you're looking for something like, say, 90 degrees to the right, which would be clockwise, this is the same thing as 270 counterclockwise. So it's the same cheat code. If you want to go to 70 clockwise, then that's going to be the same thing as 90 counterclockwise. So this would be the same cheat code for 270 clockwise. Okay, so with that being said, we are looking at what happens if you're rotating around some other point that's not the origin, 0, 0. Okay, well, let's move on down here and get into it. All right, here's example number 1. Looks like we have a triangle sitting in quadrant 2. You need to pay attention to that these are not blocks of 1, they're blocks of 2. Same thing on the y-axis, they're blocks of 2, not blocks of 1. So this is not going to be a fraction, this point of rotation. That is what we call the point that you're rotating around. It looks like it's going to be the order pair -5, 3. So you do have to pay attention to the little details. All right, so let's get into this. All right, rotation about a point that is not the origin. We got a triangle ABC that has vertices -8, 5, -6, 9, and C is -3, 6. We're going to graph triangle ABC, which is what this is, I believe, and its image. So this is your pre-image, which is your original figure. After a rotation, 180 degrees, about -5, 3. Well, that's that point of rotation that I just said. All right, so we're going to graph ABC. Okay, we've already got it. Boom, there it is. Map the center of rotation to the origin. Okay, that's going to be step number 2. So to map the center of rotation to the origin, we're going to translate the center of rotation along the vector. Okay, it's in component form 5, -3. So they changed the signs. Then translate the vertices of ABC along the same vector. Okay, interesting. I'm not sure this is the way that I would have done this, but I'm going to go along with it. I'm going to see where they're going with it. After you teach something for this is year number 27, you do find faster and easier ways to do things. So this is not exactly the way that I would have done this. Okay, I'm all right with that. All right, so they change it from a -5 to a +5. They changed the 3 to a -3, and they switch it to component form. See, they're no longer parentheses, but they're weird looking bracket thingies. So this is their vector. All right, so they already know a little plugging and chugging. All right, so they're going to take their A, which is -8, 5, and they're going to plug into the vector x plus 5, y minus 3. Again, because it's a +5 and it's a minus because it's a -3. Okay, so this is what they do. They put that -8 right there. -8 plus 5 is -3. They put this y value, 5, in for the y right there, and 5 minus 3 is 2. This is going to be your new A. Okay, so then this is step number 3. I won't put that in there. I thought maybe this is what they were doing, but they're not. All right, so I'm replacing x with a -6. -6 plus 5 is a -1. Replacing the y with the 9. 9 minus 3 is 6. And for the c, replacing the x with a -3. -3 plus 5 is a 2. And replace the y with a 6. So y, which is 6, minus 3 is 3. All right, so there is your new A, your new B, your new C. All right, so next is they are rotating 180s about the origin. All right, so this is your cheat code, which means your X changes signs and the y changes signs. Now, you might have a student who thinks that actually is a negative. That negative right there means you're changing the sign of whatever the number is. So if it's a positive number, it becomes a negative. If it's a negative, it becomes a positive. So it doesn't literally mean, hey, it's going to be negative on both. Change the signs is what it means. So this -3 will become a +3, and this +2 becomes a -2. This -1 becomes a +1, and this +6 becomes a -6. 2 becomes a -2, and 3 becomes a -3. All right. Step number 4. Map the center of rotation to its original position. All right, so they're going to map the center of rotation to its original position. That means they're going to translate the center of rotation along the vector -5, 3. So they're going back to their original -5, 3. All right, which means what they're going to do, a little plugging and chugging. So then translate the vertices of the rotated triangle along the same vector. All right, so this 3 that we got from up here is going to sub in for the x. That means I'm putting the 3 right there. So 3 minus 5. 3 minus 5 is a -2. -2 is going to replace the y, so -2 plus 3 is a 1. All right. Let's see. Replacing the 1 for the x, so 1 minus 5 is a -4. Replacing the -6 for the y, -6 plus 3 is a -3. All right. And replacing the x with the -2, -2 minus 5 is a -7. And replacing the -3 for the y, -3 plus 3 is 0. So one more time, please, please, please pay attention to these boxes being 2. So I don't want you to think that -2, 1 is sitting in the wrong place. It is not. It is left to up 1 because this is a measure of 2 for every single block. So -4, -3 is -4 to the left, down 3, and -7, 0 is left 7, up 0. So this original pre-image triangle ABC has been rotated left 1 turn, 2 turns. If it had been 270, it had been 3 turns and then back to the original. So we have quarter turns in geometry: 90, 180, 270, 360. All right, so there is your answer. Okay, I tell you what, since the check is up next, I do want to show you guys on the GeoGebra what this will do for you instead of doing all of these single steps. So if you have students that are visual, or if you're one of my students looking at this and you're a visual learner, you can go to GeoGebra and it will do this for you. So I'm going to draw my original triangle, and that was the polygon. Make sure I got my polygon. All right, so -8, 5, -6, 9, and -3, 6. So you can see that I have to go up to 9. I might have to move this out a little bit so I can get my triangle in there. All right, now I'm going to go to my polygon. Okay, so -8, 5 is left 8, up 5. There's my A. B is -6. That's going to be left 6, up 9. There's my B. And C was -3. That's left 3, up 6. I'm going to shoot back to my A to finish out my closed figure. All right. So you can find the distances over here if you want to. But I want to rotate this 180 degrees about a point that's not the origin. So I've got to put my point out here to tell the computer program what to rotate around. So I'm going to come over here to point, and I'm going to put a point at the, remember this is called the center of rotation. So my center of rotation was at -5, 3. So I'm going to go left 5, up 3. I'm going to put a point there to rotate around. So this is my center of rotation. And remember, I'm going to do a 180 degree turn to the left, because if they don't tell you which way to turn, it is counterclockwise. That means to the left. So 90, 180, I'll sit somewhere like here. And, as you can tell, that is the answer right there. All right, so I'm going to tell my computer to rotate. So I'm going to go to the third icon from the right, and I'm going to click on rotate around a point. And you'll notice down here in my lower left, if you don't have the point there, it's not going to let you do this. So you have to have that center of rotation. All right, so I'm going to click rotate around a point. I'm going to click on the figure. I'm going to click on the point. I'm going to get this little box right here, and it's telling me, okay, I need to put in what I'm rotating. I'm rotating 180 degrees counterclockwise, so you can change it if you need to. I'm going to hit OK, and there is my figure. All right, it's a little bit blown up because it looks a little bit bigger than the one that's in your book, but you can see they are the same. So our -2, 1, -4, -3, -7, 0 were our primes. And there it is. A prime, -2, 1. B prime, -4, -3. And C prime is -7, 0. So the same numbers I would get doing it, what I would consider the long way. Now, listen, if it's me, and I've taught geometry for 27 years, and I have a lot of visual people, I would have grabbed patty paper, and I would have had them lay that patty paper on top of the original figure, and I would have had them trace out the x-axis, y-axis, the pre-image, which is your original triangle ABC, the point of rotation, which is the -5, 3 point, and then I would have had them literally stick their pencil or pen on that center of rotation and turn the patty paper 2 quarter turns to the left, and voila, you've got your figure. All right, so that is your super secret shortcut way. Most of the tests now are on computer. All you got to do is take that patty paper and lay it up to the computer. Trace out your original figure, trace out your X and Y axis and your point of rotation. So you have your like guiding lines. Turn that sucker 2 quarter turns to the left, and boom, you've got your original figure. All right, so we're ready for the check. Triangle PQR has vertices P21, Q24, and R51. We want to graph the original triangle and its image after a rotation of 270 degrees counterclockwise around 7.5. All right, so everybody, put your 3 dots on your grid. Now, of course, this computer program is not going to let me do this. All I can do is pull it up because all I'm doing is looking at the book itself. So I'm going to use my GeoGebra to do that. So I'm back out all of this, get rid of everything, and I'm going to put my polygon at the 3 points, P21, Q24, and R51. All right, here we go. P is 2, 1, so that's going to be right 2 up 1. And I can change this A to P here in a minute if I need to, so you're not confused. All right, Q is 2, 4, that's right 2 up 4. All right, and R is 5, 1, that's right 5 up 1. 2, 1. Oh, I think I put Q in the wrong place. Oops. Let me back out of this. I messed up. Sorry about that. Okay. I'm getting distracted. My teachers are screaming at each other across the hall. All right, so 2, 1. All right, 2, 4, 2, 4. Nothing like getting lesson plans together for next week by screaming at each other across the hall. All right, and R is 5, 1, so right 5 up 1. All right, there we go. All right, so if you are confused by this, I'll change this to a P. I will change E to the Q, and I will change C to the R, because I don't want you guys to be able to follow along. So there we go. There's our original figure. All right. So go ahead and draw that in your book. P, Q, and R. You're sitting in quadrant 1, and I'm going to turn this sucker 270 degrees, 270 degrees counterclockwise, about 7.5. So I need to have my point 7.5 there. So I'm going to come over here, draw my point 7.5. That's right, 7 up 5, So there's my point of rotation. Now, it doesn't label that any letter, so I'm just going to keep it A, if that's okay with everybody. All right, so remember, I'm going to rotate this figure around this point 270 degrees to the left. So 1 turn, 2 turns makes it directly opposite the pre-image. 3/4 turns, I'm going to have it sit somewhere right in here. And listen, if you're a visual person, you need to get used to kind of visualizing where it's going to be. Because on any kind of standardized tests on the computer, more than likely they're going to only ask for, okay, maybe what's P prime or what's Q prime or R prime. So if I know I'm turning this figure around this point, 270, 1, 2, that's 3/4 turns. So it's going to sit somewhere right up here. So, maybe they might have ordered pairs in your multiple choice answers that are negatives. And of course, that's not going to happen because they're going to end up being both positive. All right, so let's do it. I'm going to go to my figure, center of rotation or around the point. Let's go to my figure, click the point, 270 degrees. And again, I wanted to be counterclockwise. That is your default. I'm going to hit OK, and there it is. There's my new figure. Remember that we call that the image. So P prime is 310, Q prime 610, and R prime is 37. So there's your super secret shortcut way for GeoGebra. Or you can get your piece of patty paper, trace this out, trace the point, the y-axis and the x-axis just for points of reference. Turn that sucker 1, 2, 3 to the left because this is counterclockwise. And boom, you're going to get your figure. All right, you guys, so that is going to be it for me because next up is your practice. Try example number 2 on your own, and I hope you guys have a great day.